Welcome to the integration of powerful ideas through robotic manipulatives as we guide students to technological fluency through effective classroom management. Imagine these scenes from two different classrooms. In one classroom, students are building cars using Lego gears, wheels, and motors. One group is trying to make the car go as fast as possible, while another group writes a computer program to control how the car reacts when it bumps into a wall. Meanwhile, in another classroom, students are creating an interactive garden. They use a wide variety of materials to create flowers, insects, and hanging lanterns. One group writes a computer program to make the wings of a bee flap up and down, while another group programs the lanterns to glow different colors when someone comes near. In many ways, the experiences in the two classrooms are similar. In both classrooms, students are using the same robotics technology. They are learning similar math and science concepts and developing similar technical and programming skills. The differences between the two experiences are also important. Different students are attracted to different types of robotic activities. Marina Umashi Bears, author of Blocks to Robots, is an assistant professor at the Elliott Pearson Department of Child Development and an adjunct professor in the Computer Science Department at Tufts University. Bears draws clear parallels between using robotics in the early childhood classroom and developing the skills students need in the 21st century. Robotics combines the physical and creative opportunities of building and manipulating objects with the problem-solving and collaborative experiences of learning to program their objects to move in a desired manner. Early childhood is a time for assisting children to build a foundation that will help them interact with the world. There has always been a general agreement that young children tend to find success when they learn by doing and when they engage in project-based activities. Children experience huge developmental changes in their cognitive and language abilities during their early years. At an early age, technology can impact a child's personal, social, and emotional strength. Because technology in the home is becoming ever more available, understanding the role of technology in early childhood development is increasingly important. Researchers have used the term powerful ideas to refer to a set of intellectual tools that are important anchors in education. As students engage in authentic project-based learning activities, certain powerful ideas arise and give children a new way of thinking about science, math, and social studies. The order in which children develop their own intellectual abilities will determine the rate at which they acquire new language. The powerful idea of technological fluency is derived from constructionism. Constructionism is a theory of learning as well as a strategy for education. In a constructionist setting, students will learn by creating, discovering, programming, and designing objects that are in line with their own interests. Powerful ideas must connect to our students in a number of ways in order to be successful in the classroom. Cultural connection. An idea must be relevant to the student's cultural background in order to be meaningful and productive. Personal connection. An idea must be in line with the student's interests in order to evoke an emotional response. Domain connection. An idea can be an organizing principle for a number of related topics that can be collaborated under one heading and taught as units. For example, young children might be interested in the domain of dinosaurs. This can be used to teach them about subjects such as extinction and animal habitats. Epistemological connections. An idea must reflect back to our own way of constructing knowledge about the world. In order for an idea to be interesting to a child, it must coincide with their way of living, thinking, and learning. And lastly, historical connections. Ideas that are truly powerful will stand the test of time, and their influence will be felt by many generations. Teaching powerful ideas through robotic manipulatives. One powerful idea is cause and effect. Students can design and create cars with light sensors. Another powerful idea, the properties of magnets. Students can explore and discuss the properties of magnets. A pre-programmed car made of Legos can be used to test the strength of magnets. Map skills. Students can create a flat floor map made of Legos that resembles their own town. A school bus can be made from Legos and programmed to move through the town map and stop at certain stops. Storytelling and comprehension. Students can create a replica of the main character in a classic story and program the arms and legs to move in simple back and forth motions. Light and sound. Students can build a robot and add a light sensor, which enables the robot to distinguish between light and darkness. The light sensor will enable it to read the light intensity in the room. A sound sensor can be added for the robot to detect decibels, which is the measurement of sound pressure. Incorporating storytelling and narrative into robotics can also strengthen reading, writing, and literacy connections. Students can keep journals about their design process. 4 strategies that have been successful in engaging a broad range of learners are: 1. Focusing on themes, not just challenges. 2. Combining art and engineering. 3. Encouraging storytelling. And 4. Organizing exhibitions rather than competitions. Robotic manipulatives certainly do play a powerful role in implementing technological fluency through effective classroom management.